My name is Arturo Fagundo. I am one of the software development managers for the Site Recovery Manager product at VMware. I'm also one of the original developers. I'm here with my colleague.
My name is Larry Touche. I'm from Netapp. I'm the technical marketing engineer at Netapp for the Netapp Site Recovery Manager adapter, and I'm also the technical marketing engineer for our SnapMirror protocol, which is the replication product that you use with SRM and Netapp.
And so we're going to talk to you today about Site Recovery Manager and specifically how to use Site Recovery Manager with Netapp. We do have, well, let's go into the agenda. Hopefully you guys have seen this disclaimer more than once by now. Some of this is forward-looking. Things may change, so on and so forth. We do have quite a few slides to go through, and there is a demo at the very end that covers how to use SRM. Well, it's a presentation on using SRM for failover and failback with the current version of the product. I'd actually ask that you try to hold questions until we get through the slides. There are some lulls in the action in the demo, and that would be a good time to ask questions. So what we're going to cover, though, is first we're going to go into what SRM is under the covers, give you sort of an overview of the product, what it's supposed to accomplish, and getting a little feedback here. Maybe you should stand a little further back. Yeah. We'll also go into your initial interaction with the product, and then I'll turn it over to Larry, and he'll talk to you about how SRM integrates with SRM. How Netapp integrates with SRM, what the Netapp storage adapter looks like, how to set up that adapter, and how to upgrade to the unified version of the SRA. And then, as I mentioned earlier, we're going to have a demo that walks you through the process of failing over your data center with SRM, and then what is involved in actually doing a failback with the current version of the product. SRM. SRM leverages your existing investment in vSphere, both ESX and vCenter, to provide a disaster recovery workflow engine. What it does is it simplifies the process of setting up your DR plan. It gives you a point-and-click interface that you can use to configure protection and then plan out your recovery process. It also lets you do non-disruptive DR testing. And then, obviously, when you're ready to actually fail over, when you're ready to recover from a real disaster, it calls down into the underlying storage, it fails over the storage, and it'll promote the LUNs at the remote site. It'll present the VMs on those LUNs to the remote ESX servers, and it'll actually register them and power them on. Effectively, SRM turns your manual runbook into an electronic runbook. That makes it easier for you to both create your DR runbook and for you to maintain it and document it later on. We do leverage your existing investment in vSphere. So we do have an implicit assumption that you'll have an instance of vCenter at both the protection and the recovery site. It's really geared towards peer-to-peer protection. Let's see. So the initial process of configuring protection, something I alluded to earlier, that's where you basically go in and tell us what VMs you want to protect, what VMs you really care about, and you'll group them into these abstractions called protection groups. And the protection group is the minimal set of VMs that we can fail over as a unit. Once you've configured protection at the protection site, you'll go into the recovery site instance of SRM, and you'll create a recovery plan. And the recovery plan, again, this is your electronic runbook, and it can include one or more protection groups that were configured at the protection site. When a disaster actually occurs, everything goes red. We actually give you a big red button you can push or a big red button you can click. And what that does is it initiates the process of failing over from your recovery, from your protection to your DR site. And one of the first things we do is we call into the underlying storage. We fail over that storage for you. And then we promote the LUNs at the replica images at the recovery site. Again, we know about the virtual machines ahead of time. We register them with VC and ESX after the LUNs are promoted at the recovery site, and then we go through the process of powering them on for you. It's important to note one of the big advantages one of the strong features that SRM gives you is the ability to do non-obtrusive testing of your DR plan. You configure your protection, you create an electronic runbook, a recovery plan. You can run that recovery plan in one of two modes. One mode is in test mode, the other mode is as a real failover. In test mode, again, because it's non-disruptive, it means that you get a chance to prove out, you can validate your DR plan without taking down anything in the production data center and without having to take any kind of a maintenance window. The DR test is a little different. When you execute a DR test, obviously you don't want to interrupt the replication or interfere with the production workload in any way. What we do is we call down into the underlying storage. Storage will give us a temporary copy of the replica image at the recovery site. And we give you the option when you run the DR plan in test mode to put all the VMs that are in your recovery plan in a separate and a distinct test network. And what that lets you do is it lets you identify or create an isolated network at the recovery site just for your test mode ahead of time, and we'll leverage that isolated network in order to do your DR testing. And again, we get temporary copies of the replica images at the recovery site. So the key takeaway from here is that you can do DR testing in an isolated environment, but it is the exact same DR plan that you're running. One of the other things to note is that when you run your recovery plan, we give you the ability to define a number of custom callouts or scripts that you can execute as part of the recovery. Those callouts have environment variables. One of the environment variables will be the recovery mode, and you can actually identify in your callout whether you're running in a test or real failover mode. So if you needed to execute slightly different logic in the callouts, you could do that. This being VMware and this being about virtualization, we make no assumptions about the allocation of resources. We don't assume that you've got spare allocated resources at your DR site. In fact, our initial assumption is that both sites will be active. And because they'll both be active and you've got replication potentially going in both directions, there's no exclusive protection site and no exclusive DR site. We let you protect one site to another site, and the notion of protected versus recovery site is really a question of what direction your particular workload is going in. So what does the initial interaction with SRM look like? SRM is managed through the same VI client that you use to manage vSphere. When you go into VI client the first time and connect to a vCenter server where SRM is installed, you'll have the option of downloading an SRM plugin. Once you've installed the plugin, at the bottom of that home page, if you guys are familiar with the vSphere client, you'll see an SRM plugin. When you click on that plugin, you'll get this page here, which will give you, this will be your window into the SRM configuration. The first time you connect, or when you first connect to SRM, you'll have kind of an enumerated list of the initial configuration items that you have to go through. SRM is geared towards peer-to-peer protection, which means that you have to have an instance of SRM and vCenter at your protection and your recovery site. You also you have to, because the two sites talk to each other quite a bit, the two SRM instances talk to each other quite a bit, you have to establish a mutually trusted communication channel, and that's known as the connection or the pairing process that you go through first. Once you're done pairing the two SRM instances with one another, you'll go in and configure the array managers. Now, the SRM leverages your existing storage and replication technology. What we do ask, and what we get from Netapp, is a very small piece of glue logic that is installed on the SRM server itself, and that gives us the little bit of control we need in order to initiate things like replication discovery, test failover, and failover operations. And obviously, but you have to configure the array managers before you can actually do anything else. And then the next thing is inventory mappings. We don't assume that the two data centers are identical in any way. We assume that you may have different networks, resource pools, and VM folders at both sites. And the only thing we ask is that you tell us how to map one set of resource pools, networks, and VM folders from one site to the other site. And then once you're done doing that, you can actually go in and tell us about what virtual machines you're protecting. And that's the process of configuring protection groups. So how do we leverage the underlying array-based replication? Well, the first thing we do is when you go through that process of configuring the array managers, we call down into the underlying storage, and we get a list of replicated devices. And the replicated devices may be LUNs, they may be NFS volumes. It doesn't really matter. We take that group of replicated devices, and then we go to vCenter, and we find out what those devices, what data stores those devices correspond to. Once we know the data stores that correspond to those replicated devices, we can find out what virtual machines are actually provisioned off of those data stores. So now when we've got all of the virtual machines that are replicated, you can use that to configure your protection groups. And once you've configured your protection groups at one side, again, then you would go over to the recovery side. And at the recovery side, the recovery SRM instance will go back and talk to the protection side instance of SRM. It'll get that information from the protection side instance of SRM, and you can configure your recovery plan based on that collection of replicated VMs that we discovered from the underlying storage. So to illustrate this concept, I know there was it's a lot of different terms going out. I've got this configuration of LUNs, LUNs 1 through 5, and they're used in three slightly different ways. LUN 1 is used to provision a single VMFS data store, and in the case of LUN 1 and VMFS 1, we have all of our VMs provisioned off of that one data store. LUNs 2 and 3 are used to provision a single multi-extent data store. And again, in this case, we've got a bunch of VMs that are provisioned off of that one data store, VMFS 2. LUNs 4 and 5 are a little different. They are used to provision two different data stores respectively, VMFS 3 and 4. However, there is a VM that spans those two data stores. Now, each of these groups of devices are form three different data store groups. In the case of LUN 1 and VMFS 1, we calculate that there is a one data store group that has that one data store in it. In the case of LUNs 2 and 3, we calculate that there's another data store group there too, because there's, again, one VMFS volume that is used to provision multiple VMs. And then, again, in the case of data store group 3, we've got two data stores in there because we've got VMs that span more than one data store. And the data store group is the minimal set of data stores that can be failed over to recover a coherent set of virtual machines. The data store group calculation is something we use internally. Within the SRM server itself, the abstraction that you'll see is this notion of a protection group. The protection groups correspond one-to-one with those data store groups. But a protection group is not a collection of data stores, it's a collection of virtual machines. Now, as I mentioned, when you're done configuring your protection on the protected side, you would go over to the recovery site and you would create a recovery plan based off of the protection groups that you've defined previously. The recovery plan can contain one or more protection groups. In the case of this recovery plan 1, we've opted to include all three protection groups, and you would presumably use this recovery plan to bring back your entire data center. You could, of course, define a second recovery plan or another recovery plan that only includes one of the three protection groups. And this recovery plan would be used to recover from some partial site failure. Maybe you use it to recover from the loss of an array or a set of LUN devices.
So Arturo's been explaining kind of what you do on the SRM side of things when you work with SRM in a Netapp environment. So I'm going to try to explain to you what things look like on the back end in the storage array in relation to the way Arturo just explained it. So in a Netapp array, we have a collection of physical disks or physical spindles, and we will group those into what's called an aggregate. Well, first they get grouped into a series of RAID groups, depending on how you've worked that out with your SE and your professional services guy. You'll get to what's called an aggregate, which is a collection of physical spindles. And the aggregate is what we use to create a layer of abstraction between the physical hardware and the way we want to actually lay out and provision storage. So inside the aggregate, you'll create what are called flexible volumes, or flex vols for short. And what a flexible volume is a collection of metadata that defines the size of the flexible volume, some other attributes like some whatever options you might have set on it, whether or not it's replicated, that kind of thing. And it's also comprised of whatever blocks of data anywhere in the aggregate happen to be owned by that flexible volume. So those blocks can live anywhere, and that's why we're able to make these volumes flexible. They can shrink and they can grow as you need them to. And then if you're doing NAS storage with SRM and Netapp, you would directly mount the flexible volume. That's where your data would live. So if you were to look inside the flexible volume, you would see the virtual machine home directory in there. Inside the virtual machine home directory, you'd see the VMX files or the VMDK files that make up the VM. If you're doing SAN, then we would put LUNs right in the flexible volumes. And LUNs are defined in the same way FlexVols are. They're just a collection of metadata that says that they're a LUN for Fiber Channel or for iSCSI or for FCOE or whatever, and the size that they are and that kind of thing. Now in this case, Flexible Volume 1 is holding just one LUN, LUN 1. That's an okay configuration to do. And then Flexible Volume 2 actually holds two LUNs, LUN 2 and LUN 3, and those happen to be part of the same VMFS system. This is something you'll commonly see in older is maybe a bad word, but environments using NetApp and VMware that have grown over time. So there was the 2 terabyte LUN limit for LUNs underneath VMware in the past. So if you needed to grow a data store beyond 2 terabytes, you would simply create another LUN in the same flexible volume and then create an extent. So that would be something that would give you a configuration that looks like this. You could also have LUNs 2 and 3 in their own flexible volumes, and they would still be part of the same VMFS file system. And the interaction between SRM and the Netapp SRA would automatically figure out that those two LUNs, even though they're in different flexible volumes, are part of the same data store. So when you do replication, we have a similar setup at the other site, a system with some physical disks and an aggregate. And when you set up our replication technology, which is called SnapMirror, you create flexible volumes at the destination site, one for each source volume that you have. You create what's called a SnapMirror relationship between those volumes. So we have a one-to-one SnapMirror source to destination volume, and we call that a SnapMirror relationship. And then when you initialize the relationships, it will populate them with the LUNs from the source site. So I'll explain some of the interaction that happens between SRM and the Netapp SRA when you execute some of the workflows in SRM. So the first one is test recovery. When you issue a test recovery, what happens is SRM will request a temporary copy of whatever storage objects are housing the virtual machines that are part of the recovery plan that you're executing. What this means is that the Netapp SRA will create what's called a flex clone of that flexible volume. And what a flex clone is exactly the same thing as a flex vol. It's another set of metadata that defines another volume. And this volume can have its own properties and even its own size, but it is sharing the same blocks of data that were being used by the original FlexVol volume. So it doesn't require any extra space to create this other than maybe a few kilobytes of space for some metadata until you start to write into it. So as the virtual machines boot up, that's when your storage system will start to consume space during a DR test. The virtual machines boot up, they'll generate some I.O. into their internal page files, like the Windows pagefile.sys file. There'll be a virtual machine swap file created in the data store, and you'll start to see some capacity taken out of the aggregate on the storage system. Then we'll take those LUNs, if you're in a SAN environment, we'll add them to what are called I groups on the storage array. An I group is how the Netapp system does LUN masking. So in the SAN environment, we do LUN masking, and we call that an I group. In the NFS space, we would simply create an NFS export of the newly created FlexClone volume, in this case, volume 9. Now, in the next release of SRM, we're going to have some new capabilities added into almost each workflow. I think each workflow is going to have a new capability over another. The one we'll see in testing is the ability to optionally request an update of the storage replication when you execute a DR test. So this is good for if you're patching an application in your environment, or if you've installed a few new machines into your environment, new virtual machines, and those maybe have not yet been replicated to the DR site, but you want to run a test. You don't want to have to call your storage admin, ask him when the next replication is going to happen, or open a ticket and say, could you please update my replication? And he's going to say, I don't do that in the middle of the day. It only happens at night. You'll have the capability in SRM to actually check a box that before it executes the disaster recovery test, it will issue a replication update. So whatever changes you made to your environment, you can get those to the recovery site and then run the test. From there, the workflow is the same as what I just described. I forgot I had an animation here, so that's basically an animation of what happens in that case. So the other workflow we have is the recovery workflow. So this works similar to the way the test recovery workflow works, except that instead of creating a FlexClone volume that's based on the original FlexVol volume, we simply break the mirror relationship. We'll make it so that no more transfers are occurring, and then we promote the destination flexible volume to be a live volume, so it's readable and writable. And from here, the workflow is the same as it is in test recovery. If it's LUNs, we add them to the I groups that SRM requested we add them to, or if it's NAS, we create exports and we give the ESX hosts permission to those exports. So in the next major release, again, a new feature we're going to get is this capability to do what's called a planned failover. So in the planned failover, the workflow changes a little where SRM will shut down the environment at the source site, shut down all the virtual machines, and then deprecate the storage there so that it becomes read-only, and then issue a replication update so that any changes users were making to data before the virtual machines shut down will get replicated to the DR site, and then the workflow from there is similar where we add LUNs to I groups or create NFS exports and the virtual machines start up. So this is a very cool feature which enables you to do some planned DR, take a very short outage to avoid a disaster like a hurricane or floods or stuff that you know is coming, maybe even an earthquake if things are shaking and you hit the button fast enough before everything gets too crazy. So I'll talk about the Netapp adapters specifically for a few minutes. So we've got different adapters for SRM out there. There is the 1.4 adapter, 1.4.2 adapter. These adapters came in two different flavors. There was one for SAN environments or one for NAS environments. So if you're using an adapter with the version number of 142 or less, then you have to have a separate adapter whether you're using SAN or NAS. And you can put them both in the same environment, have some virtual machines in NAS data stores and different virtual machines in SAN data stores, and that's okay. That wouldn't support a certain use case that some customers wanted to be able to use, where in the case where you would have a virtual machine with its system drive or its C drive in an NFS data store, but that virtual machine also maybe had iSCSI RDMs connected to it for some applications that you were running. So that's a virtual machine that's using both NFS storage and SAN storage, and these independent adapters couldn't support that with SRM. So as of version 1.3, we combine the two adapters into one, and we call that a unified adapter. And if you're using 1.4.3, you just need the one adapter, and it doesn't matter what protocol your virtual machine's sitting on. You can protect it with SRM, even if it's using a mix of all three. So some of the new features in the 1.4.3 release, I'm just going to go through these really quickly because we didn't want to take too much time here in these. So multi-protocol support is what the release is all about. One of the other things it does is fully thin provision your DR test environment. I showed you earlier we have layers of storage in a Netapp array. We have the physical disks, the aggregate, the flexible volumes, and the LUNs. And at each of the places, the flexible volume and LUNs, we can do thin provisioning at multiple layers. So one of the things that the Netapp SRA will do is turn on thin provisioning at every layer when we create that flexible volume for DR testing. So you do not have to reserve extra space in your aggregate that's equal to the size of the flexible volume. If it wasn't thin provisioned and you had a 2 terabyte aggregate and you had a 1 terabyte flexible volume, you would need a 1 terabyte free in your aggregate to do DR testing. We don't want you to have extra capacity to do DR testing. So we automatically thin provision everything. At the end of the test, it all gets destroyed anyway. Another feature is support for a product we have called Multi-Store. Multi-Store is a product that lets you carve up flexible volumes and other resources from a physical array and put those into what's called a virtual filer or a V-filer. And you can have up to 60-some of those on one physical controller. And they're like virtual machines, but they're on the Netapp array, and they're like small little virtual filers that only own specific flexible volumes. You can add those virtual filers into SRM just like if they were physical storage arrays. And another feature is non-quiesced SMVI snapshot recovery. And this one's a little complex. If someone wants some details on this, maybe find me in the hallway afterwards. But very quickly, what this allows us to do is use the specific snapshots from the storage array that another product we have called SMVI creates. SMVI is a product that can create quiesced snapshots of virtual machines on the fly. We don't yet have the capability to use those quiesced snapshots in the SRM recovery plans. We're working with VMware to get that into a later release. But today we can support non-quiesced backups created with SMVI in SRM recovery plans. So it's kind of we implemented part of the code that we'll use later with SRM when we implement the rest and get the support for fully quiesced virtual machines. So when you go through the workflow that Arturo described when he was showing you what the interface looked like, you'll click on the Add Array Manager link in that interface, and that will bring up this GUI where you select the type of array that you're going to add to the storage system. You'll give it a name, and then you'll give it some other information. The name is just a cosmetic thing. You'll give it the IP address, which is the administrative address. You'll give it some NFS IP addresses. I'll explain what those are later. You'll put the credentials in there, click the connect button, and you'll get a little black check in that box if it was successfully able to connect and read the storage. The next screen will show you that it detected that array has what's called a peer array. So that peer array is the array that contains some storage that's being replicated from the array that you're adding right now, and it'll give you a device count of how many it sees. The next screen, you'll click Add to add the recovery site array. Put in the credentials here in just the same way that you do for the protected site, and then click OK. And if everything has been discovered properly, you'll get the green check mark there next to the relationship between those two arrays. At the end, here's where you'll see the discovery of those data store groups that Arturo showed earlier in the slide. So in this case, if you look at the very top one, if you could see it, it's I think it says data store group SRM8A, SRM8. So in my lab, SRM8A was one NFS data store, and SRM8 was a different NFS data store. But I had a virtual machine that had virtual disks in both of those data stores. So SRM properly detected that and is forcing me to contain both of those data stores into one data store group because they're both necessary to be recovered at the same time to recover that virtual machine. So you'll see everything is working out in this GUI if you get this output at the end. So a little bit more information about this NFS IP addresses field. This is where you tell the SRA which IP addresses on the NetApp controller are the ones that are serving NFS. A NetApp controller can have multiple IP addresses. Some you might use for CIFS, some for iSCSI, some for NFS. You might share IPs between CIFS, iSCSI, and NFS. And you might have different IPs for administration. You'll put those addresses in that box. So here's an example of that. In my lab, I had the administrative network on the 10 network, and then I had these two private networks that were non-routable and could not be accessed by virtual machines or by people who were not administrators in the environment. I created two private networks. You can have as many as you want. I'm not aware of a limit. We do have some customers with 4 or 6 that I'm aware of. In this case, the blue one is the 12 network, the 12 subnet, and the green one is the 13 subnet. So what SRM will do is during the execution of a recovery plan, it will alternate between these two IP addresses as it mounts NFS data stores. So you'll be able to make use of multiple paths at the DR site, just like you are doing at the primary site if you set it up that way. So you see some of the NFS mounts that were created during this DR test were on the 12 subnet and some on the 13. A quick note I wanted to explain about upgrading the adapters. If you're in a SAN-only environment, so if you're just using one of the older adapters, 140 or 142, and you just have SAN storage, iSCSI or fiber channel, the upgrade is very smooth. You just uninstall the adapter you have, install the new adapter, and you go back into SRM, and things just keep working like they did before. When we combined the two adapters to make a unified one, we had to merge the code for the NAS adapter into the code for the SAN adapter, which means we made a fundamental change to the NAS adapter that wasn't compatible with keeping things working in SRM after an upgrade. So if you are upgrading an environment that has NAS in it, and you're going from 140 or 142 adapter to the 143 adapter, then you have to remove the recovery plans and protection groups that are using NAS storage, and you have to go into the array managers and remove the NAS arrays that you configured, and then re-add them, and then make more protection groups, which is not a difficult process. You'll see Arturo is going to go through that in the demo when we get to that. Did you? Okay, Arturo's going to explain another new workflow in SRM.
Sorry. So if you want to fail over with the current product, we've already gone through the process of what you would do to configure protection and initiate a test or a real failover. But if you wanted to fail back with the current product, that's a workflow that we think of as reprotection. And with the current product, what you would do is you would go in, you would remove the recovery plans and protection groups that you configured initially. You would reverse the replication for the underlying storage, and then you would recreate new protection groups and new recovery plans going back basically the way you came. There is obviously a lot of value in being able to validate and test your failback process before you actually commit to coming back to your original protection site. You have to keep in mind that once you fail over, that is your production environment at the recovery site. There is a Netapp tech report that was put together by Larry that describes how to do this with Netapp storage, and I'd suggest that you take a look at it if you're interested. With the next major release of the product, we will provide direct support for doing reprotection within the existing SRM product. So with the next version of the product, you'll be able to initiate a reprotect operation after you do a failover, and that will reverse the replication, change all of the SRM configuration that needs to get changed in order to go back the other way, and then obviously you'll be able to validate or test your failback workflow before you actually go back to the original site. There is another session that goes into this in more detail. I think it's at 3 o'clock today, It's one of the SRM Futures talks. So if you're interested in what it's going to look like in the next major release, I would recommend you go to that. Is the number the right number?
It's I have them backwards. That's my bad. 3671.
Okay.
Yeah. That's what I get for typing a URL instead of copying and pasting it.
Second half of 2011.
So what we'll do in the NetApp array to support the new workflow is you'll have an environment. In this case, this environment has been failed over. The NetApp SnapMirror relationship was broken, and the recovery site storage activated. So you won't see something in the GUI that actually says like failback. There's not the failback workflow. It's called the Reprotect workflow. So what the Reprotect workflow will do will tell the SRA to reverse and resynchronize those NetApp SnapMirror relationships and populate any changes that you've made at the DER site since you failed over can be replicated back to the original primary site. And as long as the type of disaster you recovered from was not the type that destroyed your storage, if you can reactivate the storage you had, then you don't have to resynchronize all the data. You can just replicate back the deltas, so whatever new data you've written there. And then the final step is in the workflow is that SRM will basically reverse the roles of the two sites within this recovery plan. And then from there, everything works exactly as the failovers you would normally do. So you would just do a planned failover back to the primary site. So Arturo's going to play the demo. Do you want to
take questions
get
now,
going on that first? Or?
Actually, we've got a couple of minutes. You want to do some questions first?
Yeah, we'll take a few questions for maybe 5 minutes before we get into the demo. Does anyone have any?
In a high availability environment, if the VMs fail, obviously they can shift over. Say in the case, primary site, protected site, only your storage, you have a copy of your storage. Can you have a recovery plan to shift your storage, or you have to vMotion all of your VMs and your storage?
Yeah, so we don't vMotion the VMs. There isn't an outage associated with running a DR plan. But to answer your question, you definitely can define a recovery plan that only covers the one storage array.
You don't have to move everything over.
No, you don't. And in fact, in the example that I showed earlier, there was a recovery plan that had one of 3 protection groups in it. Back there?
If we are using SMVI with YS snapshots, is the implication just that snapshots won't be available at the recovery site?
What will happen is because we can't support yet using the Quias snapshots, the reason we can't is because the virtual machine in a Quias snapshot has what's called a delta file on it. A delta file is it's like another VMDK that sits between the virtual disk and the I/O, and it's kind of trapping I/O and storing it aside so that you could remove it from the virtual machine or play it forward. It's like a write log, and if you have multiple virtual disks under a virtual machine in different data stores, and they all have those delta files on them, SRM doesn't properly recover them. It doesn't deal with changing UUIDs of virtual disks that are spread across many data stores. So because of that, we don't let the SRA will not let the SMVI Quias snapshot be the one that's presented to SRM. Instead, it just breaks the SnapMirror relationship, and the replication point that SnapMirror created is the one that's presented. So you don't see anything different. It's just you're not getting, the recovery is not the quiesced one. It's the one from a few seconds later, which would be like a crash consistent one. You don't see any difference in the GUI.
Multi-store support, does it do VMware or does it just use the
You're running SnapMirror from inside this vFiler to inside another live vFiler at the DR site. We can't do vFiler DR. So vFiler DR is a NetApp term. What that means is that you've replicated an entire virtual filer to the DR site, and it's in an offline mode at the DR site. It's not online. It can't be accessed. And when you fail over, you activate the DR vfiler. The vfiler DR command, when you type that command to activate that vfiler, it will automatically shut down the primary vfiler. So if we were to use the vfiler DR mechanism, we wouldn't be able to support the testing feature, because when you run a DR test, you would shut down your vfiler. Right. Any other questions? Okay.
Let's go ahead with the demo. Okay, so this is the actual SRM client window, which you'll notice as you go into the vSphere client. This is the virtual machine inventory. You go from that VI client window and select the SRM plugin. Once you're there, you'll see that in this case, I've already got my two SRM instances paired up with each other. There is, in this case, the array managers are already configured. This is a screen that highlights the process of mapping inventories from one site to another. And again, this is where you would map local virtual machine networks, folders, resource pools to remote virtual machine folders, networks, and resource pools. Once all that's configured, again, you're going to go in and create a protection group at your protected site. And what will happen is we will have discovered what virtual machines are, in fact, replicated, and you'll see that you're only allowed to protect the virtual machines that through the array discovery process, the replication discovery process, we've determined are replicated. Once you do that, and you acknowledge that that's the protection group you want to create, we actually create a placeholder VM at the remote site. So you'll notice with SRM that if you protect 2 or 3 VMs at one site, you'll see corresponding VMs created at the recovery site. These are shell VMs. There are no disks associated with them. They're just VMX files. They take very little in the way of actual storage. Now, once you're done creating the protection group at the one site, if you didn't notice, I actually went to a different VI client window. It's connected to the recovery site. And when you connect to the recovery site, you're going to go in and create a recovery plan. It's going to get information back from the protection site about the protection group. And it's going to only present you with protection groups that are already configured at the protection site. And so again, you can select one or more of those protection groups. In this case, I've selected one. After you create the recovery plan, you're presented with basically a template DR workflow. It's the same DR plan whether you run it in test or recovery mode. In this case, I'm running it in test mode. There are certain operations that are only executed in recovery mode. In particular, in test, you would not power off production VMs. During a real recovery, we actually will go ahead and try to power off the VMs at your production environment. And then we go in and try to prepare the storage. And prepare storage means something slightly different depending on whether you're running a test or real failover. In test mode, again, you're creating temporary copies of the replica images at the remote site. In a real failover, which we'll show you in a second, you're actually promoting the read-only copies at the remote site and presenting them to the ESX host. Once we've failed over the storage, we actually go through and start powering on the VMs. And with the current product, there are basically 2 priorities. Priority group 1 will power on the VM sequentially. Priority group, the normal priority group here, will try to power them on roughly in parallel. Every VM power on operation has got the same set of steps. We will optionally change the network settings for you. So if you want to customize the IP address as part of the DR failover, we'll do that. We'll optionally execute any pre-power on callouts that you may specify. Those callouts are run on the SRM server itself, not in the guest. And then we power on the VM and we wait to get a heartbeat from VMware tools. Once the VM is powered on, we'll optionally execute any post-power on callout scripts you may have specified for that VM. And again, the callouts can be specified on a per VM basis. Now, once the test recovery completes, you've got a real production version of a real live version of your production data center at your recovery site. You can use this for a variety of purposes. Clearly, the main reason to do this is so that you can validate your DR plan before you actually commit to failing over. We've heard some customers will use this to test Windows OS patch updates. before they actually commit to doing it in their production data center. Once you're comfortable that the DR plan is complete and you're done with all your validation, you would acknowledge that you're done with it, you would hit the continue button, and then we would go back and put back the storage the way it was before we started. We keep track of your test recovery runs, test and real recovery runs, and we make them available for viewing later. This is valuable for auditing purposes. There's nothing VMware specific about the audit reports we create. It's basically some XML, some XSLT. We generate some HTML. You can view it in any web browser. In this case, you can tell that I need a laptop upgrade because it takes a while for IE to come up. And it looks roughly like the view that you're presented with when you're running a real test recovery. Now that I've actually validated my recovery plan by running a test and reviewing the results, I'm actually going to go ahead and commit to failing over the entire data center. This is a potentially destructive operation because you're going to power off VMs at the production environment. So we want to make sure that you acknowledge that you really, really want to run a real failover. You'll notice here again that because it's a real recovery, we actually do go in and try to power off all the production VMs. There is fine-grained permissions control in SRM. If you want to give certain users the ability to run a test recovery but not a real recovery, you can do that. Here, again, it's the same prepare storage step. Under the covers, we're doing something slightly different. We're not creating temporary copies of the replica images at the remote site. We're actually promoting the read-only copy at the remote site to be read-write and clearly interrupting the replication as a result. This is going to complete shortly, and then what you'll see is that we go again into the process of powering on VMs again. Same set of steps, same plan. They behave slightly differently depending on whether it's a test or real recovery. It's really up to you to make sure that your test is as close to the real recovery as possible. Again, the custom callouts will behave. They can behave differently depending on whether it's a test or a real recovery. Any questions about this? Yeah, go ahead.
Yeah, I have a question. You set up a test recovery so that you do power off certain production machines. Will we do some business unit VR testing?
Mm-hmm.
We bring them up, have them access and get into the device. We don't record their changes or ship them back, but we want to make sure they can get in, and we don't want to have the production system running.
Right. Yeah, we don't actually let you do that. We do let you suspend VMs at the recovery site as part of the DR plan. But what I would actually recommend is that if you want to validate your servers, I would actually strongly recommend that you include clients as part of the DR plan, so that when you fail over, you've got clients that come up in this isolated network, and because you come up during your test recovery in a different isolated network, you can. I see. Okay.
It finished and you're in the audit. I paused it.
Okay, go ahead. Yeah.
Oops.
Oh, no.
There we go. Did it start over?
Actually, just go about halfway through.
It's not going to bring up the...
It's not going to let you do that.
Yeah, let me just... bad.
You might as well just start it at this point and just let go. We can take questions.
Okay. Well, I can launch this, right?
Okay.
Halfway?
Yeah, halfway is good. Okay, so now the DR process is completed. I've failed over. I'm going to have to go in and remove all the recovery plans, reverse the replication, remove the protection groups that I originally had set up, and then I'm going to go in and recreate protection groups at what was the recovery site is now your production data center, and then go back to what was the production data center and is now the recovery site and create recovery plans there. So here I'm in the process of creating a new protection group that goes back in the other direction. If you're failing over and back multiple times, one thing to keep in mind is the first time you fail back, you're going to have to create array managers or configure an array manager again from the recovery site. You're also going to have to go in and configure inventory mappings back from the recovery site to the protected site. Not sure if it came up here, but one of the things you'll also notice is that if you've configured your array managers already at the recovery site, then after you reverse the replication, you're going to have to go into the array managers and rescan those arrays. Basically, if you don't, what you'll do is you'll go in, you'll try to create a protection group. You'll see that we don't know about any replicated VMs, and you won't be able to create a protection group. And so when you go into the array managers, you'll get a little yellow box. And basically all that means is that we don't know about any replicated devices. You've got to go in and rescan. After you've done that, we'll discover all the replicated devices. We'll map that to data stores. We'll map the data stores to VMs. And then you can actually create the protection groups. So here, I think we're going into what was the original protection site is now the recovery site. And we're going to create a failback recovery plan for the failback process. It's the exact same workflow you went through to go one way, and now you're just doing it in the other direction. Sorry, go ahead.
Yeah, when you go back, is it just delta changes, or do you got to re-replicate everything back?
So that's the NetApp replication that depends on that, right? And if you didn't lose the storage, and you can get your storage back online, right? Then you can just do the deltas back. But if the building burned down and you lost the storage, then you're buying new stuff and syncing it again.
Yeah, how does that bring the delta back on SnapMirror if the destination had the destination has to know what the delta is?
If the storage at the primary site wasn't destroyed, right? So you bring the storage back online. There's a capability to reverse the SnapMirror relationship, and it keeps a history of NetApp storage snapshots on either side, and it'll actually do a block map comparison between it'll find the common snapshots that it has, the most recent common snapshot, and resynchronize from there. No, not if you can get your storage back online, right?
So we're showing here the fact that you can actually test the failback process before you commit to failing back to your original production data center. Go ahead.
Is there any indication on the array side about what groups are protected? Is there any push back into
No. So if you say you're looking at a NetApp administrative tool, and well, some of our tools will give you a SnapMirror status report telling you which volumes are replicated and updated. But our tools don't look into there to see what virtual machines are. We do have stuff on our roadmap though that will give you visibility into virtual infrastructures, but that's a little ways out.
Your protection group is set up, and then later on you run storage vMotion?
It's not storage vMotion. It's
He's asking about if you run storage vMotion.
I'm sorry, if you run storage vMotion after the fact. Yeah. Yeah. So if you've got a data store group and you storage vMotion VMDKs within that data store group, you're probably going to be okay. You're not going to have to do anything to the SRM configuration, but there is a small window of time between the time that you storage vMotion and the time that vMotion operation is reflected on the recovery site based on your SnapMirror schedule. And during that period of time, you may have problems if you actually have to fail over at that particular point in time. This is one of the reasons why in the next version of the product, we'll let you optionally sync up that storage before you run a test recovery or a planned migration. Now, if you storage vMotion off of a replicated data store, we'll detect that and we'll create an alert we'll put a little icon on the protection group. You'll have to go in and fix it. But there's no way for us right now to stop you from doing that.
Yeah. I've done that in my lab, and it's not very it's not really a problem. Usually, you're doing a storage vMotion because you want to do some size capacity balancing. right? So if you've got some virtual machines in a data store, and that data store happens to be already protected with SRM, and you storage vMotion a virtual machine from one protected data store to another protected data store, you'll get these little yellow icons in the SRM GUI telling you that there's another VM that it's found there, and you need to just tell it how to recover it. You just go in and kind of click a button, and it will automatically figure out and add it to the other protection group. So you can move. There is some movement of stuff around that doesn't cause issues. Yes.
If you create these plans and then you look at process data, you fail over, and then you have to delete the plans and then fail back. Is there any way to save the plans and an easier way to kind of like, bring that back?
Yeah, interesting. So you can export the plans, and one of the things that I strongly recommend you do is before you delete the recovery plan, you can export the plan, but you can't import it back in. So you can export it for auditing purposes so that you can share it with people so they know what your plan looks like, but there's no way to, I know what you're asking for. You want to be able to re-import it back so you don't have to recreate it after the fact. Mm-hmm. And right now we don't have a way to do that. With the next version of the, sorry. No, you really can't. No. With the next version of the product, we solve this by basically letting the recovery plans and the protection groups exist at both sites at the same time. And so, the question of failing over or failing back is just a question of which one's active, which one's not. And so you don't have to go through the process of deleting and recreating. Yeah, go ahead.
You have to have FlexClone, which is a license at the recovery site, which is the license for creating the FlexClone volumes. You have to have that license and SnapMirror, and then the license for whatever protocol you're running, Fiber Channel or NFS. You don't have to have that. No. For SRM? I don't know. I've actually never been on the sales side at Netapp. It's good to not know how much stuff costs because then I can build honest configurations. Yeah.
There's no automatic option
for failover.
Is there a possibility to have the script way to, okay, no one has pressed the button yet, but our building is a burning hole?
You can do that. Yeah. So we assume that most people don't want to do that automatically, so we didn't build it into the product, but you can, we create an event that gets sent up to VC, and then VC, you can associate an alarm action with that event, and one of the alarm actions could be an SNMP trap. And so if you were pretty adventurous, you could, have some sort of script or some sort of process, sitting there waiting on that SNMP trap that would then call back in through the public API for the current SRM product and kick off the failover. You want to test that really, really well before you go ahead and do it.
Yeah, because the only thing worse than it not recovering is how fast can you drive to that third site and stop it if it's going to fail over and you don't want it to, right?
Is there a white paper on this?
A white paper on automating the failover process? No. Honestly, we don't get a lot of requests for. Most people really want to be involved, have human involvement in that failover process. Sorry, go ahead.
It's probably not really that familiar with the product, but I've heard the comment smoking hole mentioned several times. That's the obvious scenario where you use this. Again, I just saw a process where it said we're going to make a decision, we're going to shut down a bunch of stuff at the primary site. So guess what? There's just a smoking hole there. So I don't quite get that part of the process. It's like that workflow would work.
If it can't access the primary site to shut stuff down because it is a smoking hole, it just skips those steps. The steps just go gray very quickly, and then it'll run through the same thing we saw. Yeah.
No, it's real disk files, VMDK files, everything. Yeah.
Yeah.
Okay.
So I'm assuming you can do this, but can you manually, using a filer, manually replicate some of the logs in your data group that's protected? If you're doing more of a, you don't have a smoking hole scenario, you're doing more of a control failover. So like, say you're a SQL partition, where your databases are, you want to take out the data as much as possible.
You could actually do something today with SRM where in the demo, you saw the steps in the recovery plan, and there's the steps where it will shut down the source site if it can, right? And then there's the steps where it begins to recover storage. You can insert the command steps, or I call them command steps, Arturo's calling them callouts. Right? You could insert a callout between those two steps that would initiate SnapMirror updates, right? So that would give you a quasi kind of way to do planned failover today. Or you could just go shut your virtual machines down yourself, go do the SnapMirror update, and then run the SRM recovery plan. So you just need to do things in that order. You do it with SRM or manually, and then in the future, it'll be a click.
Right. You said two types of SnapMirror?
SAN, two different SANs.
Oh, if you have two different SANs, you have to put them in different protection groups, but you can put them in the same recovery plan. And you can't have more than one array manager. So if you had multiple Netapp filers or even different types of filers, you could put that all in one recovery plan.
Yeah. So if you have a virtual machine with some data on one array and some data on a different array, that does not work. The virtual machine has to belong to only one array, but you could have multiple virtual machines and arrays in one recovery plan. Is there a question back there? In the white? Sorry. Or go ahead.
Worst case scenario, say you replicate every 15 minutes. 14 minutes, you go into smoking or whatever. Everything's just hard down. You then recover to 15 minutes ago, or are you still being in a consistent state?
That's your, so in that case, your RPO is 15 minutes, right? And if the failure occurs 14 minutes after your last update, then you lose 14 minutes worth of data.
Okay, but you are consistent.
Yeah, you would go back to the last recovery point.
In the white.
Yeah, not the way you see here. The RDMs work just like all the other LUNs we described with SRM. They work exactly the same. SRM will detect them, automatically connect them to the virtual machine at the other site. That works. There is a thing you have to do to make the Netapp Snap Manager product. That product depends on another product inside the virtual machine called Snap Drive. And Snap Drive talks to the virtual center server in order to manage storage. Well, once the virtual machine comes up at the recovery site, there is a different virtual center server there. So you have to type a command in the Snap Drive software to tell it what the new virtual center server is. Once you type that command, everything will work. Snap Manager for SQL will see all the old backups that you created at the protected site. You'll see them in the GUI at the recovery site, and you can use the callouts in SRM to make that command happen. Yeah, you put it in the SRM recovery plan, and SRM will execute it in each guest as it's recovered. There's a Netapp TR 3822 that talks about doing exactly that. You're replicating the snapshots there with SnapMirror? Yeah. So today, all you can do is recover to whatever was the last SnapMirror update that you made. Those other backups are there at the recovery site. So you could, after recovery, you could access those backups if you wanted. They don't get destroyed or go away. They're there and available, but there's no capability today when you run the SRM recovery plan to select which one of those you want to recover to. You're always going to want to try the absolute newest one, right? Because that's the shortest RPO.
Yeah. That's right, yeah. If you get a lot of them, yeah. Well, I mean, just to clarify, right now you can create customization specs in VC at the remote site and associate those customization specs with SRM without having to go to the CSV file. It's a very laborious process, and that's why we have the CSV file, which is really sort of an interim solution to get people to provide a scalable way for doing that. With the new version of the product, we're getting away from customization specs altogether. You will be able to specify IP addresses within the SRM UI itself. We will still support the CSV file, for backwards compatibility reasons, but you won't have to do that.
All right, thanks,
Okay.
everyone.
Thanks a lot, guys.